Welcome back everyone to the final 9.1 video. If you can believe it, this has been so many videos for 9.1 because there's a lot to say about confidence intervals. And there's even much more to say, but we will wrap it up here talking about how to determine what sample size you should use whenever you're estimating a proportion. And this is something that goes into determining, like, wow, we took a sample of 100 people, but is that enough? Should we have taken a bigger sample? Maybe a smaller sample would have been appropriate. And probably it's better in general, to take a bigger sample just to be safe. But we'll see that we can actually figure out what is the exact sample size that we should use to estimate a population proportion, which is the P there. And this one really is looking kind of like a rho, to be honest. It's looking like this Greek letter rho, but that's kind of actually the Greek R, but it just resembles a P. Now, we will get rid of that one because we're using P. Don't worry about it. Now, we will have this formula right here. The sample size that you should use, what you will do is you will take, if you have maybe from years past or maybe some similar experiment has ever been done before, you will need to have something to stand in for a point estimate. So for P hat here, this can be some type of a prior estimate of the proportion. Like I said, it could be from a previous experiment, or maybe somebody calculates this every year consecutively. You can just use last year's value for this. We will use the P hat, we will use the Q hat, which is 1 minus the P hat, of course. And then we will also use the critical value for whichever confidence level we want to use. So we found those just a moment ago, how to find for each confidence level the corresponding critical value that you will want to use in this calculation. And then E over here, this is the desired margin of error. And so obviously whenever you're doing things, you don't want the margin of error to be too large, and it will affect how big the sample size is if you want the margin of error to be smaller. So if you can imagine somebody studying something to do with polls, or there's an election going on, you don't want the margin of error to be so large that you could actually not determine who's expected to win. And we will see in an example right now. And by the way, I would just like to mention that if you don't have a previous value for P hat, if somebody's never done this experiment before, or whatever the case may be, it's actually safe to use the value that goes 0.25, because it's actually, this will give you the largest. If you use 0.25, this is the largest value that's even possible by multiplying a P hat times a Q hat. If you imagine all different values that you could use, maybe P hat is 0.9, Q hat's 0.1, stuff like that. 0.25 is the maximum value you can get by multiplying any particular P hat times the corresponding Q hat. So this will give you just a very safe, this is the largest kind of sample size that you could ever come up with. And like I said before, it's always better to use a larger sample just to be safe than a smaller one. And what we will do whenever we calculate these, if we end up getting a decimal, say the n that we come up with is maybe like 101.5 or something, of course you cannot sample half of a person or half of a candy bar or something. You should round up to the next whole number. We will always take the ceiling. If you can remember, there's this ceiling function. So we would end up making 102 because we want to be safe rather than sorry and use the larger sample size. So we would round up always. It doesn't even matter maybe if this was something that should round down, like I will change it to 3. So that in general you would round this down, but we would choose to round up because we want to take the larger sample size. Now why don't we do an example where we're going to calculate this one. We're wanting to find what sample size should be used in this case. And what we're dealing with is a television sports commentator. He wants to estimate the proportion of Americans who follow professional football. What sample size should be obtained if he wants to be within 3 percentage points with 95% confidence? And so 3 percentage points, what that's talking about is he wants the margin of error to be 3%, which that means we can call it 3%, of course, as a decimal goes 0.03. So he wants to be this close, no farther than this, from the point estimate on either side. And we're using a 95% confidence level. Let's see. He uses a 2010 estimate of 63% obtained from a Harris poll. So what this is talking about is somebody has already done this poll before, and he's going to use what they came up with. He wants to use that as his initial p-hat. He will use that as his point estimate. And he's going to determine how big his sample should be. So remember the sample size, it goes p-hat times q-hat. I'll just write down the formula again here. It goes p-hat times q-hat, and then it goes times, we would like to use the critical value, divided by e, and then this one goes squared. And we would like to use here for alpha, it goes with the 95%. So what this means, can you tell me what is the alpha value that goes with 95%? Of course, you said the right thing, which is 0.05. So that means that alpha divided by 2, why don't we just plug in some values that we have. The p-hat is 63%, so that goes 0.63. The 1 minus this, which is the q-hat, 1 minus 0.63, it should be 0.37. And then we will go times, maybe you can recall, what did we get from this one? Z alpha over 2, and alpha over 2, we're doing z 0.025. And then we're going divided by the margin of error that's desirable, which is the 0.03. And then we will square this. So this value here, z of 0.025, what did we get for that one? Z 0.025 is this one, right, which 95% confidence level. We're looking at this row. So the z alpha over 2 for that one was this guy, the 1.96. So we will go into there with that one, 1.96. Now let's see if we can get all this into the calculator. It's going to go 0.63, and then times 0.37, and then it's going to go times the 1.96 divided by 0.03, and then we want to square that one. So we will go squared. What is this? So we will get that his sample size, and remember we need to round up no matter what, but if we round this one up to the nearest whole number, which we would do anyway because it goes 0.9, we will go 995. This is the sample size. He should use no less than 995 people. So he could use more if he wanted to, maybe just make it more appealing by using 1,000, but this would be the perfect acceptable sample size, is 995 people. And then we will calculate this one if he does not use any prior estimates. Remember, that just changes the formula a little bit. We would just go 0.25 in place of the p-hat times q-hat, and then everything else will stay the same. It will go 1.96 and then divided by 0.03, and then we will go squared. So how is that going to turn out? 0.25, and then we will go times 1.96 over 0.03, and then we will square this one. And what are we going to get? See, now the sample, if he does not have a prior estimate, he will need to use a larger sample of 1,060, but you cannot have 0.1 person, of course, we should round up. 1,068. This is how big his sample should be this time. So it's pretty straightforward calculating this one. You're just going to plug everything into the formula like so. And that does it for 9.1. Thank you guys for watching, and talk to you later.